Hi friends. In this video, we're going to talk about operations on square roots. So this is part of the sequence of square root videos. If you're having trouble evaluating square roots, I want to refer you back to some of the previous videos. And here we're going to be combining square roots using addition, subtraction, multiplication, and division. So here we go. Remember when we were talking about like terms? And we talked about how numbers are like terms with one another, and if you have an x and a 4x, those are like terms. And we said like terms have the same variable. Now, the other way that that can be interpreted with like terms is if they have the same variable or the same square root, or both. Let me show you what I mean. So here I have 2 square root of 2 plus 3 square root of 2, and we notice that they have exactly the same square root involved, and we have just numbers, no variables. So these square root of 2 are the same. And, oh, I don't want green. Let's go with blue. This 2 and this 3 are like terms. Let's see, and let's label those 2 square roots of 2 as the same. And that means that we can add them. So I like to think of this as 2 of something plus 3 more of that same thing is going to give me 5 of that thing. Same way we did, and it's not exactly the same, but so I'm going to write it in a different color. So I want to think 2x plus 3x is equal to 5x. 2 of a thing plus 3 more of a thing gives me 5 of the same thing. It can look a little scary when we have all these square roots here, but it's really the same concept. Okay, let's look at a different one. 4x square root of 3 plus x square root of 3. I'm going to add in that sneaky coefficient of 1 here, just to remind us it's there. So this is really 4x square root of 3 plus 1x square root of 3. Now, we're going to notice that those square roots are exactly the same. And then let's look at what's on the front of them. 4x and 1x are like terms. And that's important. We have the same square root and we have like terms on the front. So that means I can combine them. So I have 4x times a thing plus 1x times that same thing is going to give me 5x times the exact same thing. So 4x square root of 3 plus 1x square root of 3 is 5x square root of 3. Okay? All right, let's look at another one. Here I have 2 square root of 3 plus 3 square root of 2. When I look at the square root of 3 and the square root of 2, those are not the same. Oh, there we go. That means that I cannot combine. And so it is already in its most simple form of 2 square root of 3 plus 3 square root of 2. So we would leave that alone. There's nothing I can do to combine like terms. All right? Let's look at another one. I have x square root of 3 plus 2 square root of 3. All right, my square root of 3's are the same. That's good. But then let's look at what's on the front. I have an x and a 2. These are not like terms. Since they're not like terms, can't combine. So keep in mind, the square root part has to be exactly the same, and what's on the front of it has to be like terms for us to add and subtract. Now here's some good news. When we multiply and divide, well, when we multiply and divide, it's kind of like multiplying and dividing fractions. We don't have to have a common denominator, and when we multiply and divide square roots, we do not have to have like terms. So we want to think about when we multiply together, we want the number part to get combined. So in this situation where I have 2 square root of 2 times 3 square root of 2, this would be 2 times 3. And then we're going to multiply it by square root of 2 times square root of 2. So 2 times 3 is just going to give me 6. Square root of 2 times square root of 2 would give me square root of 4, which we could simplify. We know that square root of 4 is 2. So this would be 6 times 2, which is 12. The important part here is grouping up the numbers on the front together, 2 times 3, and grouping up the square roots together, square root of 2 times square root of 2, combining each of those, and then finishing out that multiplication. Let's look at another one. Here I have 4x square root of 3 times square root of 5. All right. We have a 1 on the front. It's a sneaky one. Doesn't change anything. So I'd have 4x times 1 gives me 4x. Then square root of 3 times square root of 5. I could write in that additional step. For x square root of 15. I would want to think to myself, does 15 have any perfect square factors? It doesn't. So we're just going to leave it as 4x square root of 15. Keep in mind the number on the front and the number inside the square root are separated. We can't break into that square root. Only perfect squares can break out of it. All right, let's look at another one. I have 2x square root of 3 times x square root of 3. So I'm going to combine the numbers on the outside. 2x times x gives me 2x squared. And then I'm going to combine the square roots. So this is square root of 3 times square root of 3. You might not need to write that step, and that's okay. Square root of 3 times square root of 3 is square root of 9, which is 3. So I would have 2x squared times 3. One more step to be done. 2 times 3 is 6x squared. All right, I want to look at some examples that involve parentheses. So let me throw those up on the board. Okay, here we go. So when we see parentheses, don't worry. We're just going to use our same rules. It just looks a little bit different, but it still refers to multiplication. So when I see this 2 square root of 7 multiplied by parentheses square root of 2 plus 1, I want to distribute 2 square root of 7 times both things inside the parentheses. So this would be 2 square root of 7 times square root of 2 plus 2 square root of 7 times 1. I'm not going to write that 1, but we know it's there. let's think about what we can combine. Square root of 7 times square root of 2 is just going to give us square root of 14. So this would be 2 square root of 14 plus 2 square root of 7. Now, this is where it becomes very important to be able to recognize like terms. Notice that first I'll check those square roots. They are not the same. Can't combine them. It doesn't matter that the front part are like terms. Those 2's are like terms because square root of 14 and square root of 7 are not the same. Can't be combined. So our final answer would be 2 square root of 14 plus 2 square root of 7. All right, the next one, really similar. I just threw an X in there. We're going to distribute 5 square root of 3 to both things inside the parentheses, so the x square root of 2 plus square root of 3. All right, so first I would have 5 square root of 3 times x square root of 2, and then plus 5 square root of 3 times square root of 3. So we're going to do a little bit of cleanup work here, where I have 5 square root of 3 times x square root of 2. I'm going to group that 5 and x together on the front. So I'd have 5x times square root of 3 times 2 is 6. So that would be 5x square root of 6. Then when I have 5 square root of 3 times square root of 3, we could think of this as 5 square root of 9 or just 5 times 3. So my final answer would be 5x square root of 6 plus 15. Now notice I can't combine those any further because this term has a square root of 6, this one does not. So they cannot be combined together. That is our final answer. It's not cute, but that's what it is. All right, my next example, I have 2 sets of parentheses. So the first one, parentheses, square root of 3 plus 1. And then the second one, multiplied by the first, is parentheses 2 square root of 2 minus square root of 3. We're going to use FOIL to simplify this. And remember that we're going to multiply the first, then the outside, then the inside, then the last, which is how we multiply any binomial together. All right, so first terms together, square root of 3 times 2 square root of 2. And I'm just going to write each of these out. We'll do them all in a different color. Outside terms, I would have square root of 3 times negative square root of 3. Inside terms, positive 1 times 2 square root of 2. So this would be plus 2 square root of 2. And then last terms, 1 and negative square root of 3, which would be minus square root of 3. All right, so we did our FOIL piece. Now we just need to do some cleanup work to finish the problem. So I have square root of 3 times 2 square root of 2. I'm going to rewrite that as 2 square root of 6. Next, I have minus square root of 3 times square root of 3. This would be minus square root of 9 or just 3. Then a 2 square root of 2 and minus square root of 3. Now, you might say, this is a huge mess. Surely we can combine some things together. We have 2 square root of 6 minus 3 plus 2 square root of 2 minus square root of 3. It is so tempting to combine some things together. But first, let's check. Do we have the same square root appearing anywhere? No. That means nothing can be combined. So our final answer is this fairly unattractive 2 square root of 6 minus 3 plus 2 square root of 2 minus square root of 3. Remember, addition and subtraction can be written in a different order. So if you were to write it as, say, 2 square root of 6 plus 2 square root of 2 minus square root of 3 minus 3, this is totally the same. Addition and subtraction can be written in either order, and it's totally fine. All right, I want to finish with one more parentheses problem. And this one I have in parentheses, square root of x minus square root of 2 times, in parentheses, square root of x plus square root of 2. So we are going to FOIL this out. So I'll start the same way. First terms together. So square root of x times square root of x. Outside terms, that would be plus square root of 2 times square root of x. Inside terms, minus square root of 2 times square root of x. And then last terms, minus square root of 2 times square root of 2. All right, so let's look at what we have. Square root of x times square root of x plus square root of 2 times square root of x minus square root of 2 times square root of x, and then minus square root of 2 times square root of 2. Let's do a little cleanup work here. Square root of x times square root of x is just going to be x. We could also think of that as square root of x squared, which is x. Then we would have plus the square root of 2x, then minus the square root of 2x, and then minus square root of 2 times square root of 2, square root of 4, which is just minus 2. Now let's notice something super important here. I have plus square root of 2x and minus square root of 2x. Those are opposites. They are just going to be equal to 0 when we add them together. So I am left with a very nice x minus 2 as my answer, which after all the ugly answers we've looked at so far, seems like a good way to end the video on operations and square roots.